Making truly random numbers at home might be more challenging and time-consuming than you think. It might seem mundane on the surface, but it plays a vital role in our daily lives. From secure online transactions and cryptographic protocols to fair and unbiased selection processes in gaming and lotteries, random numbers form the bedrock of many of the systems we rely on. They ensure fairness, unpredictability, and above all, security. But generating truly random numbers is not as straightforward as it seems. If you are thinking of generating random numbers in your head, simply just don't. Our brains cannot make a sequence of random numbers without patterns emerging sooner or later. Unconsciously, we might favor certain digits or patterns or follow a specific algorithm without even realizing it. Truly random numbers will contain repeats, which we try to avoid. And while the sequence might look random at first, if we look closer at it, it might not be so random after all. For passwords, lotteries, gambling, cryptographic security, it is always best to use true random numbers. How great would it be to have a true random number generator for on your desk that spits out random numbers all day long? Random numbers that can be used for any purpose, created by an IC you can buy for less than $1. Hello, my name is Rudolf and today we are making a desk gadget that can generate random numbers non-stop with the help of a simple IC. You can simply use the IC on a breadboard or make it into a good looking PCB which you can showcase on your desk. And that is what we are going to make today. If you want random numbers in small quantities, it is better to throw some dice than trying to come up with numbers yourself. In theory, dice can give perfect random numbers, but there are some disadvantages of throwing dice. Besides that it takes a lot of time to generate large quantities of numbers, they can be biased due to the fabrication process. Minor imperfections can influence the outcome over a larger number of throws. We have to come up with something better than that. On your PC or Arduino, it is easy to create pseudo-random numbers, and while they are generally good enough for computer games, art, simulating and modeling, you can't use them if you need cryptographic security. Although reading an unused analog pin on your Arduino might provide some randomness, it is still not suitable for high-level cryptographic purposes. We can use random.org to generate any sequence we want and it's fast and free. The randomness comes from atmospheric noise and is considered true random. Alternatively, we have the option to write code that acts as a true random number generator within the Trusted Platform module chip found in most modern computer systems. But you need some basic knowledge to set it up and it can be tricky to find the exact module you have. An ESP32 can use the noise from the Wi-Fi and Bluetooth antennas to create true random numbers. These options should give you true random numbers. But are those certified? Can you check if they are working correctly or if you wrote the code correctly to get random numbers? Again, we need something better and we need more gadgets on our desk. That's where the little microchip ECC608B cryptographic coprocessor comes in handy. This little chip has a lot to offer. It can be used for secure authentication, key storage, encrypted communication, secure boot, Internet of Things and much more. But today we will only be using the hardware-based random number generation function it has to offer. It uses an internal noise source to generate true random numbers and is fully certified. The generator includes a runtime health testing protocol to ensure that the output is truly random. So once it's running and sending numbers to, for example, a microcontroller, you can be assured it is of good quality. According to the summary datasheet, the random numbers can be employed for any purpose. You can get one of these ICs for under $1. It uses the I2C protocol to communicate and there are Arduino and ESP32 libraries available. After setting up the IC for the first time use, we can create about 43 32-byte random numbers per second and use those for a random number device. There is also a single wire variant available. Be careful when you're ordering one of these. Although, using a normal Arduino, you might run into memory problems and therefore I will use an ESP32. I use one of the freely available libraries in the Arduino IDE to set up and lock the IC, so it is ready for use. You must do this, otherwise the IC won't generate random numbers. Unfortunately, the available libraries come all with limitations and are really hard to read. I also run into the problem that the random number generation stopped after a while. This appears to be happening in the code, but I could not find why or how it happened. Sometimes after a couple of hours and sometimes after a day or so. The datasheet is only available if you sign an NDA, which I didn't, so I decided to take the useful parts of different libraries and just took the code needed for the random number generation and made it into a more readable code. I also added rejection sampling to the code, so we can be sure we have unbiased single digits from the 32-byte numbers we get from the chip, but more on the code later. Let's have a look at the schematics and the PCB before we go play with the device. It is a fairly complex layout to get all the components placed on a small PCB. It is a lot of solder work. I did it without special tools, just my 45-year-old leaded solder and a basic solder iron. I kept the microcontroller external to make the PCB more compact and to test different setups. There are 6 MAX7219 LED drivers on board. Each of those can drive 8 7-segment displays. The drivers are daisy chains and we need only 3 pins from the microcontroller to control 48 7-segment displays. They are placed as close as possible to the LEDs. This IC can take a lot of work out of your hands. It has features like multiplexing, brightness control, decoding of segment patterns, and it saves you a lot of pins on the microcontroller and you have much less traces on the PCB. With the MAX7219 you can use a single resistor to set the output current for all the LEDs at once. This saves you a ton of space on the PCB. I use a 64.9 kilo ohm SMD resistor for each driver to set the max output current. According to the datasheet, the P current sourced is 100 times the current entering ISET. So we have the current entering the ISET pin, which is 5 divided by 64.9 kilo ohm is 77 microamps. Now we just need to multiply this number by 100. That is 7.7 milliamps maximum current that can go through the 7 segments. I choose a high value resistor because I don't like it too bright and I want the LEDs to work for a long time. In the code we can adjust the brightness as well by controlling the internal pulse width modulator in 16 steps. I use a ESP32 with Wi-Fi and I wrote some code to adjust the brightness via a web interface. Nothing fancy, but it will do. I placed a 10 and a 0.1 microfarad capacitor between VCC and ground as close as possible to the IC. We power the max IC with 5 volts. The logic level of the ESP32 I use is 3.3 volt. I tried to communicate with the max without the use of a level shifter and it worked all perfect and reliable. According to the datasheet, the max sees the input as logic high when the voltage is 3.5 or more volts. So it shouldn't work, but it does. If I have my case ready, I will add a level shifter just to be sure. But be careful, don't do this when the higher voltage device communicates back to the lower voltage microcontroller. It won't be durable and sooner or later it will break. In this case, communication is only one way, from ESP32 to the max IC, so it is safe to use. The pins used to connect the max IC are as follow. The data in pin from the first max is connected to pin 13 on the ESP32. The load pins from all the max ICs are connected to pin 15 on the ESP and the clock pins from all the max ICs are connected to pin 12 on the ESP. The data out pin from the first driver is connected to the data in pin from the next driver. We do the same for the next drivers and the data out pin from the last driver is not connected and you can leave it floating. Then we have the heart from the PCB, the 608B IC, to create true random numbers. It is an 8-pin IC but only 4 pins are internally connected. We need ground, pin 4 and VCC pin 8. I use 3.3 volts from the ESP to power the 608B. The SDA and SCL lines from the ESP are also 3.3 volt and this way we avoid using level shifters. The SDA and SCL pins need to be connected to the dedicated pins on the ESP, which on the ESP I use are pin 21 for SDA and pin 22 for SCL, but you can change this if necessary. We need to add 4.7 kilo ohm pull-up resistors on both lines according to the datasheet and I added a 0.1 and 10 microfarad capacitor close to the IC. On the front of the PCB there are 48 7-segment displays and the 608B IC, and of course some random data and mysterious text. There are 6 rows and 8 columns. Each max IC drives one row of 8 digits. If you, like me, always seem to interchange rows and columns, just think of your eyebrows. The forward voltage of these digits is 2 volt at 20 milliamps. They are common cathode, which is easiest for the max. There is a dot, but it's internally not connected. I added a little spacing between the digits to prevent problems when mounting the digits and make it a little bit easier to solder them on the board. On the back are the 6 max devices and the male header pins for the power and connections to the microcontroller. The 5 volt connection is at the top left corner and supplying 5 volts to the LED drivers. The 5 volt is coming directly from the ESP. On the bottom is the 3.3 volt connection, which we need for the 608B IC. And I added some SMD capacitors for good measure. As you can see, it's a lot of solder work to be done. I will spare you the lengthy soldering process. Let's have a look at the device and some functions. When we power up the device, there's a small startup animation on the display. When it is done, it fills the grid with random ones and zeros. It does this until all positions are filled. The numbers are random and so is the location of the new digit. So it will take a minimum of 48 updates for the display to fill up, but more realistically, on average, we need 214 updates before the grid is filled completely. When the grid is full, the brightness increases and then dims and continues with the next randomly chosen program. This keeps going forever. We have functions that scroll the numbers on the wall screen from the left to the right. The rows fill up from the left to the right, randomly chosen of course. Spiraling inwards. Wall screen updates at once. Blinking single digits on the grid. Raining numbers. Alternating side to side fill. Ones and zeros until the screen is full. And fill the screen with random numbers one by one sliding through the grid. More functions will be added soon. I like the fill and replace single digit the most. It is the most peaceful and relaxing. There are 9 different animations. Each time it starts with filling the grid with random numbers for a certain time. When done, we generate a random number between 0 and 9 which corresponds with one of the animations in the code. If we want to change the brightness, we can do so via a simple web interface. There are 16 steps to choose from. Let's have a quick look at the code and the simple library I wrote. The code is about 785 lines long. We will just look at some of the basics in the code. As I said before, I could not figure out why the 608B stopped generating numbers with the existing libraries. That's why I made my own, very basic library to get random numbers from the device with the ESP32. If you want to test the code on the ESP32, just download the zip file from GitHub and install it as follows in your Arduino IDE. Go to Sketch, then Include Library, add zip library and choose the zip file. Done. Now you can use the library. There is an example included to get random digits and you can easily set the range. To lock the device, you can use the SparkFun library, link in the description. They also sell breakout boards with the ECC608B. Check it out. Just upload the code and follow the instructions on the serial monitor and within seconds it is all done. In the LED control library we need to make a little change to get it working without error messages from the IDE. First install the library from within the IDE. When done you need to go to the map where Arduino IDE is storing the libraries. In my case it is in Documents, Arduino, Libraries, LED control, SIC. Now open the header file named LED control. We need to comment the following line. If you are done, save the file. Now we are set to use the LED control library with an ESP32. Here is the code for the PCB. We have a couple of includes, LED control for the 7-segment display, TRNG to control the 608B IC, and some libraries so we can adjust brightness of the digits in a web interface. We create an instance of the TRNG class, tell which pins we use for the MAX7219 and how many devices we have. We also define the rows and columns we have on the PCB and we make an array for all the digits and a 3-day array for the positions of the digits on the PCB. When a new number is sent to the max, we add a little scramble animation and we can set here how many times we want it to scramble and the delay in between before the new digit is displayed on the screen. We don't want duplicates in the scramble, so we initialize the array with a value of 10 on all positions, which of course is a non-valid value for a single digit. We do this so that all places are always replaced with a new number ranging from 0 to 9 and occurring only once per ramble. And we create an instance for LED control. In the setup we turn on all 6 MAX ICs and set the brightness. The next part is for the web interface. Have a look at it if you like. If you want, fill in the SSD and password for web access. You can start the ESP32, it will send the used IP address to the serial monitor. Copy it and paste it in your browser. Before we go to the loop, some simple animations are shown on the grid. And last in the setup, we fill the screen with ones and zeros. In the loop we start with fill with random numbers, and after that we let the 608B randomly choose a program to run. So far there are 9 options. All options are made into separate functions. The total code is about 785 lines long. Have a look at it, and if you have any questions or feedback, please leave a comment. If you want random numbers the easy way, you can always buy a random number book. You won't be the only one. Please like and subscribe to my channel for more awesome content.